I think this is going to be a fun one because we're going to be taking our auction app and we're going to rewrite one of the modules into a totally different language. I'm going to do Python just because I feel like that's a language that I think is pretty common in the world at large, though maybe not as much so in the people who regularly do this video. And I think that'll be really cool because I think we've been doing a lot of things and we've been doing things with Rust just because Rust is the language we happen to use as kind of the language we were implementing stuff in. And I think when you do that, there's a risk that it's a little bit unclear, which things are Rust things versus which things are Golem things or I guess WebAssembly things. And I think this will be really nice because we'll just do a totally different language and we'll see kind of things being a lot different, what's the same. And so we'll see what are Golem things versus what are Rust things or Python things. So I am going to probably switch up between a couple of different screen shares here. But the first place I'm going to take us is just the Golem website. And so we've got this nice learn page. Come on. And there's materials for all these different languages. So let's just go to the one on Python. And let's take a look at this for a sec. So this says that the way we compile WebAssembly components in Python is with this tool called componentize.py. So this is kind of going to be the equivalent of in Rust, we used Cargo. We use Cargo, which is kind of the build tool for Rust, the common one. And we in particular use this Cargo component extension for it, which kind of teaches Cargo about WebAssembly and the component model. And similarly here, we're going to use this componentize.py thing, which is going to give us a tool for compiling our Python program to WebAssembly. So for every language, there's going to be some separate tool that is going to be kind of the tool for that language. So this is the one we're going to want to use for Python. And then it says for Golem, we want to use a forked version of this tool because we want to pin all these dependencies to the right versions because all this WebAssembly ecosystem is developing quite quickly and not all these versions are exactly binary compatible right now. And so it just says download a pre-built binary from the following address. So I'm going to go there. And it's just taking us to this page for this Golem Cloud. I think we highlighted this before, but just for folks who haven't seen it, this is the repository for everything open source Golem. And right now, there's some stuff here. I think there's going to be a lot more stuff here in the future. So you can see here that right now there are forks of tools for various languages. So here's that componentize.py one. Here's one for JavaScript, but this one is still being kind of worked on. So this is not fully ready yet. You've also got some other things here, you've got our fork of request, which is the library for doing HTTP and Rust. We've got this is going to be available soon, but we've got the Golem version of the CLI in Rust that's going to be open sourced and people are going to be able to contribute. And we're going to have lots more stuff in the future here. So I think what we talked about last time, if you're interested in adding any type of language specific support for one of the languages that you like to work with, this is a great thing to contribute to. But right now, we're just going to be using this componentize.py. And in particular, we're going to be using this release that we got directed to. And so I think the only thing to notice here is that there are versions that are built for specific operating systems and architectures. There's the underlying source code. So if we wanted to kind of build from source ourselves, we could, but I want to do as little as we have to do here. So what I would just do is I'm on a Apple Silicon, and so I can just do this Arch 64, and I'll be good to go here. So I download that, And then I think you may not be able to see, let's see. Yeah, let me switch to my desktop for a second. Yep, and I've got that. I can just extract that, and I just get this executable program. And this is just a binary, basically a command line program. And so you just want to symlink that, or you can copy it to your binaries folder. You can do whatever you want to do there. But when you're done with that, if I pull up, let me pull up a terminal here, and let me share that. So now if I do, let me spell this right, componentize I, right? It's just like doing git or whatever. This is just a thing I've got now, and it's got some instructions here, and we'll come back to these in a second. But let's now go back to our browser here. And now that we've got that, let's follow the rest of the instructions here. And so this is the easiest way to get started once the tool is installed, is to use the Golem new command. And so this is the same command that we used before when we were working with Rust. And so let's just take a look at that again. So I'm not going to need the, oops, let me make sure. Sorry, I got to keep switching my screen share here. I guess I could share my whole desktop, but I try not to do that just in case anyone says anything crazy. So let's see. Okay, so I've got my terminal here. Let me maybe bump up the size of this a whole bunch. Okay, hopefully folks can see that okay. If not, give me a little thumbs down or just comment in the Discord and I'll take a look at that. But okay, so we've got this. And so if you remember, we can do Golem, and I'm going to start with this list templates command. And we saw this before, but we didn't need to pay quite as much attention to all of it because we're just kind of showing that it existed. But so what this is going to do is this is going to list all of the templates, or I think in the future we're going to call these examples of doing Golem projects in different languages. And all of these are actually open sourced. So if you go back to that Golem Cloud open source repo, there's one of the repo, or if you go back to that, I guess, domain or organization, there's one repo in there called Golem examples. And it's got the source code for all of these. And you can submit a pull request yourself to add other ones. So like, I think this Rust to-do list, one of my colleagues, Terry, should develop that, and he contributed that. And we may have him on at some point talk about that. So if you're doing something and you think it could be useful for others as a starting point, a great thing to do is to contribute as an example. And I think over time, these are going to probably get more full featured, and maybe we're even going to need to tier this and stuff, because right now we generally, like for some language, we have kind of a couple of them, but you could imagine this being like much more full featured applications that would get you a lot closer to a particular thing you want to do, versus right now, I think these are more kind of demonstrating just like how you would do basic setup in a particular language. But anyway, you can see these are organized by languages. So we've got like C, Go, we've got a couple of different Go ones, we've got a Python one, we've got a whole bunch of different Rust ones. But for our purposes here, this Python one is the one we care about. And so we see this is called Python Minimal Actor. And it's described as a simple stateful Golem actor written in Python with no dependencies on external services. So that sounds like a good starting point for us. I think my plan here is I'm going to just start by pulling this down, and we're just going to kind of look at it, see how it's done, maybe try kind of creating a WebAssembly component from it, just to kind of, I guess, try out with the training wheels, and then we'll go back to our auction app, and we'll just basically cut over one of our services there to use Python instead of to use Rust. Okay, so we've got this Python minimal actor. So I'll try to remember that. And so then The next thing we do is we use the new command. And this takes 2 arguments, I believe, one of which is the template name. That's just called template. So again, going back here, it's Python minimal actor. Maybe it should be Python actor minimal for consistency here, but right now it's Python minimal actor. And then the second argument is the name of the component we want to create based on that. And I think since we're just doing this to kind of show this, I'll call this hello world. And so I'll hit return here. And so you see what's done is it's created this example basically in the current directory. So I've got a hello world in the directory I'm in. And it also gives us some helpful information here. So it says, see the documentation about installing tooling. Okay, check, we did that. And then it's got these 2 commands for us to use. And so it says to generate the bindings from the WIT file. Remember, that's the WebAssembly interface type. That's the protobuf of WebAssembly. We use this componentize py bindings. And then to actually package our code up or compile it down to a WebAssembly component, we do componentize py, and then we do componentize. And then this is basically the name of like the main Python file in our application that is like the entry point to it. And then this is the name of the WebAssembly component that we want to create based on that. So, okay, we got that. Let's switch over to our IDE and let's actually look at this. So one sec here. Let me just change our sharing permissions. Let's see this. All right, so right now we're just in our auction application here. I haven't made any changes from last time. And so I'm just gonna go open, and I'm gonna go to my desktop, my Golem CLI, and here's my hello world. So let me open that up, and let's take a look at that. And so we can see this one is, I mean, pretty minimal, but I guess that's kind of Python 4.8 is a little bit less like build files and stuff that you would typically see. We basically got 2 files. So one of them is the kind of file that we've seen before. So here's our WIT file. Here's kind of our protobuf file. And so here is our interface, right? Just like a protobuf file, it says, okay, there are basically 2 things you can call on it. In this case, it's kind of, I guess, a counter API. So I can add a long, or I can get the current value of a long. So we can think of this as like a counter service, which fair enough. That's a perfectly good hello world here. So this is generated for us. And then the other thing here you can see is there's this thing, which is kind of a Python implementation of this. You can see this isn't entirely happy right now. And it's not happy because we haven't generated those bindings yet. So now that I'm in here, let's, I believe it's componentize py bindings. Okay, and now let's look at this. So this has used the WIT file to generate these Python bindings. So this is a little bit like how in Rust, when we had the WIT file, and then it would kind of automatically generate the WIT data types here. And so here, if we look at this, we see it's got this class hello world. I mean, some of this stuff I don't think is a little bit maybe like the boilerplate to just get all this to work. But you can see that it's generated these exports here. And so it has this thing called Golem Component API. And it has these 2 abstract methods, right? Add, that's going to take a value, and get, that's going to give us back an integer. And both of them, these are just abstract, right? So they're just throwing these not implemented errors. But this, just like in Rust, when we used cargo component, we got like the Rust trait that represented the WIT interface. Similarly, that's what componentize.py is doing for us, or -py. is doing for us in Python. So we've got this interface here. And here we didn't really define any like other types in the WIT file. But if we had those will be created as well. And we'll see that when we move to the auction application. And then what I've got back in my main is essentially an implementation of this thing. And so you see that this is implementing this interface. And so now I'm just going to go back for a sec to grab those instructions again. So let's run the second command, componentize Py. And now instead of doing bindings, I'm doing componentize. So this is actually going to create the WebAssembly component based on this program here. And then main is pointing to where this code is main.py, right? And hello world.wasm, I can change that if I want to. That's just the name of the WASM file that it's going to give me. So hit that. And it says component successfully built. And now I have this hello world.wasm thing. And at this point, this is just a WebAssembly component. This is just a template that can get uploaded to Golem. And it's not really any different of if we went back to let me see if I can go back to our auction application here. Hold on, file, new window. Right, in our auction application, the output of everything that we did was similarly, maybe we don't have let's see, do I have the target folders here? Was similarly this lib.wasm. So we've taken this like totally different path of we've used Python versus we've used Rust, but at this point we just have a WASM program. And that's something that we can go ahead and we can upload to the Golem Cloud as a template. And in terms of kind of being runnable or anything like that, there's really no difference between one WASM program from Rust and a WASM program from Python in terms of the semantics of their execution. If you're comparing different languages, some languages are better at producing kind of faster, smaller WASM files. So like Rust is very good at that. I think Python is not as good at that. I think sometimes if you look at like the size of these lib.wasms, they can, or I mean, the lib doesn't matter, but the WASM files, they can be larger. So I think we'll see that if we upload one of these components, it can sometimes take a little bit longer to upload. But beyond that, there's not any difference between these. So, okay. So I think that was good for just having a basic understanding of, oh, I'm sorry, I think why my screen sharing got paused there. Oh, maybe it was specific to that one. Anyway, so I think that gives us a good overview of how we do things with Python. And now I think we're ready to take that and actually do that with our auction application. But maybe before I do that, I'll just check in with our audience here. Does anyone have any questions on what we've done so far? Is this all making sense? Okay, cool. All right, so then let's go back to our auction application. And just, I guess, a little bit of a refresher. We developed our auction application to have these two different modules. You could call it, or I mean, you can call them, I mean, they're really just two different types of workers, two different worker templates. So one of them is this auction registry, and that's going to essentially be a singleton in our system. And what the auction registry is going to do is it's going to let you register a new auction as well as create a new bidder. So you could think of this as kind of like the eBay homepage in terms of auctions of I can do the global state things. I can create a new auction, I can create a new bidder, or I can get a list of all the auctions. But then all the other logic is going to be delegated to these individual auctions. And so each auction is going to get its own worker, and that's going to make our auction house very scalable, especially if we do something like we put caching in front of this get auctions, because the only time that you're kind of sharing this auction registry is when you're creating a new auction, which is going to be orders of magnitude less activity than the interactions with the auctions themselves. And each time you create an auction, it's just going to give you back an auction ID that's going to be a handle for you to talk to the particular auction worker that is doing your auction. And the auction worker is the one that's going to have the functionality you expect for an auction of you get to bid on the auction, eventually get to close the auction, and so on. And the other thing that we did in the past is we had kept these two worker templates very separate. They both had their own data model type, and we could see there was definitely some overlap between them. But at the time, we decided we wanted to not kind of refactor that into a common dependency, but to keep them separate and be as modular as possible, even though that created a little bit of code duplication. And that's going to pay off for us a little bit here, because what I think we're going to do is we're basically just going to like blow away all the code in this auction here, and we'll replace it with Python code. And because we didn't introduce any shared dependencies here, we're not going to need to do anything to our auction registry. We're just going to change the auction. So that's kind of the like classic microservices story, right? Of there was some corporate reorganization, and the team that was doing the auction service isn't around anymore, and so the new team is doing it, and they like Python, so they're writing the whole thing in Python, right? So what I think I'm going to do here is I'm just going to blow away these three files. In fact, I'll just blow away this whole source directory. And so then remember, we've got these two different projects. So I'm just gonna navigate. Let me see, where am I right now? Hold on. Okay, I was already in the subfolder, so sorry. So if I'm in this parent folder, then I've got subfolders for both the auction and the auction registry. I want to work with the auction right now, so I'm going to navigate into that folder. And so again, a little bit of the nice thing of having this like WIT thing here, this protobuf-like thing, is the WIT or the protobuf doesn't change when we change languages. This is exactly the same. And so I can take this, and let me do my componentize py bindings, and let me run that. And so let's look at what it's generated for us here. So it's generated for this new bindings folder, which has these exports. And let's look at these this time, because they're going to be a little bit different. So again, we have this Golem component API. And we can see that it's given us methods based on each of the parts of the interface here, right? So here are the three methods we had were initialize, bid, and close auction. And those indeed initialize, bid, and close auction. And we can furthermore see that types got generated for these things that were types that we referenced in our definition here. So like here, we said that when you bid, you give a bidder ID. And here, oops, let me go back here. Here we got this thing, it's a bidder ID. And you might have noticed here, I mean, partly just, I guess I've got the Python tool, I think it's PyLance or whatever it is installed here, but I'm getting all the IDE support that I would in Python with that. So you can see it created both these interfaces here, as well as it created these data types that they referred to. So again, very, very similar to what cargo component was doing in Rust. I mean, maybe actually a little bit nicer. I mean, just in terms of, it kind of gave us everything right here. I mean, there's definitely some of this weirdness of like this init and stuff. But again, I mean, Rust definitely had its own weirdness. So I've got that. And so if we go back to our other Hello World program for a second, and we look at that, let me just switch back to that. So we're basically at the point where we've got the WIT file, we've got these exports. And so what we need is our equivalent of this main.py. And so maybe what I'll do, just because I like making my life easy, is I'll start by copying this and we'll just update this to do what we need. And so let me do that. So I will switch back over here. All right, so we had our bindings, we had our width. So I think this just went in the main thing here. Maybe so I'll just put main.py here. And oops, I think I copied the wrong thing. Let me just go back there and make sure I actually copy this. There we go. Okay. So now obviously I'm going to have to update these methods to conform to the interface here. But one thing that is worth noting here is I think this is one area where Python is definitely easier. The whole thing of like having some global state is way easier here, right? Like in Rust, we had to do all this like crazy stuff, having like the lazy value and having like the helper method to do it. And here it's just like, you want global state? Here it is. Just define it. So again, kind of depending on how you feel about mutability versus immutability, maybe this is good or bad. They're kind of language trade-offs, but I think this probably feels like a pretty native Python program. There's not a lot that has like different here other than maybe like this thing in what we're doing. Let me just quickly check in with questions here. Okay, looks like we're good. So eventually I want to produce a WebAssembly component from this, but I think we can probably try this out. If I try to do that right now, I'm going to get a failure. Let me just copy my little command here. Oh, that's kind of weird. I think sometimes this may be the thing of like Python not being as strongly typed as Rust, so that's not the greatest. But that's, I guess, what we get when we work with Python. But let's try to update this here. And so we're going to need to implement each of these methods here. And so what I can do is I could go to my exports and this thing, and I can grab each of these guys, and I can bring them up to here. And these don't need to be abstract methods anymore. And then you can just see I'm getting a couple of compilation errors, or maybe not compilate errors from my IDE, that it's not finding these things. So I believe, yeah, so from the exports here, I can just import that Golem component API thing. And then from typing, I can import that optional thing. So now, again, all of this is compiling, and you can see that this is giving me kind of pretty nice IDE support here. And now I just need to implement this. And I think I'll take a similar approach to what we did with Rust initially, where I think to get things going, I'm not going to kind of create the domain versus the WIT versions of each of these data types. I'm just going to use the WIT data types right now. It'll probably be a good refactoring to do in the future. But here is where I would just kind of maybe go back to the logic of the Rust code and say, what was some of the logic here and how do I replicate that? And so here, if we had this the state thing, Let's see, that was define a data model here. And so the state of the auction was basically, we had a possibly initialized information about the auction itself. This contained like what the name of the auction was and so on. And then we possibly had a winning bidder with a winning bid price. So this is obviously kind of very strongly typed and very, very Rust. I'm definitely not going to pretend I'm like the Python person, but I think a fair translation of that would be basically a tuple of none and none. And then we can just think about how we would implement each of these things. So here, and again, this is where like this is like all funny to me because yeah, I'm used to coming from like very strongly typed languages, so like this would kind of blow up in my face because this would say like, well, this is a thing of none and none, so how can it possibly be assigned to anything else? But here, I mean, in a way, it's I think yeah, maybe not being strongly typed at least makes the code look very simple. But if we go back to our original code, we said the first element in this essentially tuple was the auction. And so what it would mean to initialize the auction would just be to set that to this value we're initializing. Then here, if we want to bid, so let's think about the logic for bidding here. So I think we basically wanted to see if there was a winning bid or not. And then if there was not, we would automatically be the winning bid. And if there was, we would see if our price was higher. So let's do that. Though I see, well, maybe one had a question, but I'll keep going, but definitely. Oh. Yeah, so Juan, I totally hear you. So Juan says, my Scala brain is getting anxious in this kind of code. And I totally hear you, right? Like my point is not you have to program in Python or you should program in Python. And I mean, probably, I mean, you can do type annotations for some of these things, even in Python. So I'm not even saying like this is the perfect way to program in Python, but more like I think you're saying here that like you're not having to do a lot of Golem specific stuff here, right? Like if you like the more like Rust style, or hopefully soon we'll be able to do like Scala style, you can do that. If you come from Python and this or some variant of this is what you do, you can do that too. Like I think the overall idea of Golem is kind of versus like you having to like come to us and do things a different way for us. We want to go to you and we want to let you do things the way that you're already doing it. So yeah, if you want to write a different way, a different language, you totally can. But I thought this would be nice just to show a very different language than Rust. So for the bid, I think we could similarly, like in a way, write some very simple code. So I don't know why I'm even doing winning bid. So let's see how well ChatGPT did here. So we're going to take out the winning bidder ID and the winning price from the other piece of the state. And then we're going to say, well, if there is no winning bidder ID, or the price is greater than the winning price, then okay, then we want to set our state. So then we're going to set the state to be our bidder ID and our price. And then this, I think it kind of made this up because I don't think this is actually the correct syntax here. And then otherwise, we need a string here. So I think we said something like bid too low. Oops, didn't have an extra. Okay. And then if we want to close the auction, Well, so we can look at the state. We can say, we can unpack it into winning bidder ID, win bidder price. If there is no winning bidder ID, then there is none. And otherwise, I don't know if we really want to update the state here. We could, but I mean, I think maybe we want to leave it as is. That's a little bit of a question here. But then we just want to return that winning bidder ID. So now we've got an implementation of our program. And then again, I can do that componentize pi. And then I've got that auction module. And that's essentially what there is there. So I think you can see with that we're not having to we're not having to do a whole lot different than what we would want to do in whatever language we're working in. Now, again, maybe we don't like Python. It's not like we have to work in Python, but if we are, we can write our Python in basically any way we want to write Python. And I'm not going to say this is like the best Python in the world, the way you should write Python. That's just not my thing. But however you want to write it, as long as you implement these interfaces, which are pretty straightforward interfaces, you can write it. So with that, then I think, let's see if we can do our final step here. So I'm going to just grab this auction thing and just move it to my desktop and move it to my Golem CLI folder. And then let me see if I can upload this. Second. Just want to get this right size. All right, so I'm uploading this, and this will take a little bit longer here because it's just the Python WASM files are significantly larger, so it just takes more time for them to upload. But there we go. While I'm blabbing about how long they take to upload, they have uploaded. And so we can see we get basically the exact same information that we got when we uploaded a Rust component here. So we've got a component ID. This is version 0, right? It's called Python auction. Here is the size. I think maybe we can actually, maybe after this would be fun to compare this and see what it's like versus the Rust version of this. But you can see this is about 28 megs. So yeah, relatively large. But then I think the most important thing for user perspective is you have exactly the same API here, right? So we can initialize this with this auction ID that has an auction ID, a name, description, limit price, expiration. We can bid, which has bidder ID, and is either going to give us a success that has no information or failure with a string. And we can close the auction, which is optionally going to give us back the winning bidder. And this is the exact same set of exports that we got when we uploaded the version of the auction worker based on Rust. And that means that the auction registry or users can interact with it exactly the same way. So I mean, it's kind of the Golem version of like the microservices story, right? Where like we made this big internal change of like literally just blew away all of our code and completely rewrote it in a different language. And for everyone outside of that Golem worker, it's exactly the same. So yeah, let me maybe back to here. And I'm just going to stash these changes for a sec. Just so we can maybe do that comparison with the Rust version. So if I'm in Rust, again, now I have my Rust code again. And so I can just do Fargo component build. It'll take a minute. I'll grab all these dependencies. And so now, let's see, design place. Oh, I think I needed to, oh, right. I needed to get rid of these. So this would actually build the individual component instead of the whole thing. So let me just get rid of that. And then I think I can get this to actually just build. I'm going to turn it here. And so I got WASM release. All right, so I've got this lib.wasm here. So this is our, oh, and sorry, I realized I didn't update my screen share. Let me do that right now. Sorry about that. So basically all I did was I just did cargo component build release here in the old version. And so I got this lib.wasm, which I'm going to bring to desktop here. And maybe I'll call this Rust auction.wasm. Right, it's okay. And let's see. Yeah, so let me see if I can share my screen so you can see this. 1 second. So let me share my desktop here with you for a second. Okay, just make sure I get the right one. So let's grab this lib.wasm. So this is the Rust version I've created. Where'd that go? There we go. All right, so this Rust version, I get info about this. This is 225 kilobytes. All right, I go back to this one here, 20 megabytes. So the Python files are quite a bit fatter, you could say, which I guess is maybe one thing the Python folks could work on for their compilation to WebAssembly. But it doesn't particularly matter for you, other than the files are just going to take a little bit longer to upload. And probably if you wanted the most blazing fast performance, you were not working with Python anyway. There are different trade-offs that kind of lead to that language. So yeah, so I think that's Python, and you can see we haven't even taken the full hour here, which I mean we went over on some of them, but is maybe kind of a good sign that it's pretty straightforward. There's some complexity in just how we do this, but there's the Golem complexity really doesn't change with the languages, right? Once we kind of get some of these basic concepts of like we have this WIP file, it's like a protobuf file, we use whatever tooling we use, it's not that different. Juan has a question of in terms of execution time, is the Rust generated WASM faster, Python 1, and what's its memory footprint like? So I don't know the particular numbers for the Python 1, but I think it would be fair to say it is not going to be as performant as the same code written in Rust. And maybe some of that can evolve over time. There's I think kind of an interesting, like, I guess, design question for the people who are developing this functionality to compile a language down to WebAssembly. Kind of how much can you optimize from a language that's not as optimized? I think if you're going from Rust to WASM, you kind of have a very easy job there because Rust is already very performant versus with Python. I think there's like an interesting challenge of like, can you, like, by doing this compilation process, like make code that was slow really fast, or are you limited by just some of the inputs that you get with Python? I'm not sure how much of that is kind of can be improved by that compilation process versus is just that's what happens when you start with Python. So I don't think you can completely escape the language trade-offs that you make by going to WebAssembly or using Golem, right? I think we saw with Python that like it was not as strongly typed. I think, right, if you're using Python, you're probably not expecting it to be as performant, but we also saw, I think the code was like, in a way, very simple to write, other than maybe being scared about the not being as statically typed and not being compiled ahead. But obviously, you can also use Rust, and you get different trade-offs of you maybe have to deal with cloning things, but you get something that's going to be very performant and it's very strongly typed, and you can be at other parts of that trade-off if you want to, if you do Go, and right, you have a different set of advantages and disadvantages there. So not arguing for one language over another, but just you can use all of these languages, and it's pretty easy to use any of them. And it's also, I don't think as we saw, it's quite easy to mix and match them and to have one worker written in one language and one worker written in another. I mean, maybe we do something where based on your team, or one is much more performance sensitive than the other, that different languages make sense, just like other application code you have. Yeah, so I think the way that the Python compilation works is I mean, Python kind of goes to C, and then C goes to WebAssembly. But yeah, I mean, I'm sure there's some limitations there. Okay, well, yeah, we're about 10 minutes before the hour. Maybe I'll just put it out again if anyone else has any questions, but otherwise, have a fantastic long weekend. Maybe it's not quite as long a weekend in Europe, but that's kind of the end of the summer. So hopefully everyone is doing fun stuff and having a great time. All right. Well, thanks so much, everyone. In terms of things that are coming up, I think next week we're going to have a new release of Golem. It's going to have a couple of changes to our naming conventions. So I think I talked last week about we're going to, instead of using instance to refer to an individual worker, we're going to use worker. We think that's just a better terminology for that. And then to refer to the template for a worker, we're going to call it a template versus a component. So getting a little bit away from the WebAssembly terminology and just trying to make it more generically accessible. That's also going to come along with an update to the latest version of all these WebAssembly libraries, as well as a new Rust-based CLI, which is a lot faster. I was just getting a demo of that before we hopped on here, and it was much snappier. Something that maybe took like 4 seconds before, it takes like less than a second now. So that should be a cool thing. And then next week is WASMCon in Seattle. So I'm going to be up there as well as John, talking to everyone there. So if you happen to be in Seattle, you should definitely sign up and come. You get some cool swag. I've got like a nice Golem shirt here. And I think because of that, we may not do a symposium next week, just because I think I may be traveling back on Friday, but we'll definitely pick up the following week. And I think maybe we'll have Terry on to talk about some of the applications that he's been building with Golem. But if you have anything else you'd like to hear about, definitely reach out, and we also will have some non Golem content at some point. But I think this has been a fun series to do, and we'll definitely have more of this as well in the future. All right, take care, everyone.